Okay, let's continue our discussion of learning. Before I do that, though, one clarification. I apologize for any confusion that was caused by the mailing I sent out over the weekend about the review slides. The little caption indicated that the exam was scheduled for sometime in September. That was last year. I've corrected that. Sorry for the confusion. The slides make it clear that the exam is going to be held as scheduled on Wednesday, October 3rd, with the review session as scheduled on Monday, October 1st. What's up on the course website now is a new set of slides that you can use for review, and what's coming in about a day or so is a narrative that accompanies those slides. It'll give you some more information about what to focus on and what you can ignore, especially in Gleitman. Okay? So there's an exam scheduled for Wednesday, October 3rd, review session Monday, October 1st. Next week, we'll be talking about sensation and perception. Okay, last time I talked to you about a major form of learning discovered more than 100 years ago by a Russian physiologist, Ivan Pavlov. And the significance of this form of learning, known as classical conditioning, is that classical conditioning extends the range of stimuli that can evoke involuntary reflexive responses. What classical conditioning does is attach these reflexive behaviors to stimuli that ordinarily wouldn't evoke them. Usually dogs salivate when there's food put in their mouths. Now Pavlov's dog salivated when a bell rang off. And as I pointed out last time, the phenomena of classical conditioning are basically ubiquitous in nature. Every organism, virtually every organism with a nervous system, in fact, every organism with a nervous system shows at least some of the phenomena of classical conditioning. Pavlov believed that all learning was classical in nature. That is, that classical conditioning underlay all of the learning that organisms can do. But we now know that is very much too strong a position to take. But it does seem to be the case that by virtue of something very much like classical conditioning, we acquire a lot of our emotional responses to events. Some of our emotional responses to events are innate, reflex-like, but others are acquired through something like classical conditioning, so that we come to like some things, fear some things, be averse to some things, and so on, by virtue of the attachment of an association between a previously neutral object and some emotional stimulus. Okay. At the same time as Pavlov was studying classical conditioning in his laboratory in St. Petersburg in Russia, another psychologist, an American psychologist, Edward L. Thorndike, was studying another form of learning in his laboratory at Columbia University in New York. And this is a diagram of Thorndike's apparatus. It's known as a puzzle box. And what Thorndike was doing, Pavlov worked with dogs, Thorndike worked with cats, and Thorndike's method was to put cats in this puzzle box and let them learn how to get out. And the way the puzzle box is constructed, here's the cage, here's a door with a latch on it that's connected by a string to a paddle that's inside the cage. And when Thorndike first put the cat into the puzzle box, cat did what cats ordinarily do. If any of you ever have cats, you take them in a cage to the vet or whatever, they want to get out, okay? So Thorndike's cats would meow and they'd scramble around the cage and they'd engage in all sorts of random behavior, in the course of which they would just accidentally press on this paddle, which would pull on the string, which would open the latch, which would allow the door to open, and the cat would get out. When the cat came out, there was Thorndike, pick up the cat, dump it back in the cage, close the door. Cat would run around inside the box, accidentally trip on the paddle, pull the cord, open the latch, open the door, the cat would come out, there'd be Thorndike again, pick up the cat, dump the cat back in the box, and so on. But what Thorndike noticed was that on repeated trials, the cats pressed the lever more quickly. Here is Thorndike's actual data. This is data from his experiment. Here, number of trials out to 60. Here's the latency up to 3 minutes, actually up to 6 minutes, 360 seconds, that it took the cat to open the door. And you can see that there is a clear downward trend, so that on the first trial, it took the cat 4 or 5 minutes on average to open the door. On successive trials, to progressively less time, so that on the 60th trial, the cat would go in the cage, press the lever, and immediately come out of the cage, and of course there'd be Thorndike to dump the cat back in the cage for another trial. But the point here is that over successive trials, the latency of the escape response diminished. So apparently, the animals, the cats, were learning how to open the door, and Thorndike concluded that this learning was produced by the fact that the behavior had some consequence for the animal. It was able to escape from the puzzle box at least momentarily. Thorndike argued that this was a form of learning that was motivated by reward. On the basis of his studies of cats in puzzle boxes, Thorndike formulated a set of laws of learning. There were about 8 of these, but 3 of them are primary. They're the most important ones for our purposes, and they're the ones I'm going to focus on here. The first of these was what Thorndike called the law of readiness. And what the law of readiness states is that learning is motivated by the organism's internal state, okay? So that motivational states, whether the cat is hungry or thirsty or wants to sleep or wants to get out or whatever, those motivational states activate a whole sequence of behaviors. The cat's confined in a puzzle box, it doesn't want to be in there, and so it engages in all sorts of behaviors. The second of these laws is the law of effect, which basically says that responses that lead to reward are strengthened. Responses that lead to reward are strengthened, and by the same token, responses that do not lead to reward are weakened. So what happens is it may take 4 or 5 minutes for the animal to press the paddle on the first trial, okay? That paddle pressing response, that paddle pressing behavior, leads to the possibility of escape. So pressing the paddle is gradually strengthened over time, whereas the other things the cat's doing, hissing, scratching at the side of the cage, whatever else it's doing, those behaviors are not rewarded, and they gradually drop out of the animal's response behavior. So responses that are rewarded are strengthened, responses that are not rewarded are weakened, and then finally, for our purposes, the law of exercise, which basically says that connections between stimuli and responses are strengthened by practice, okay? Strengthened by repetition, and weakened by disuse. Connections between stimuli and responses are strengthened by practice and weakened by disuse. And as I say, there are 5 other subsidiary laws, but we don't have to worry about these right now. What's going on here are the basic illustration of what we now have come to call instrumental conditioning, or what some psychologists, notably B.F. Skinner, calls operant conditioning. There's a technical difference between instrumental and operant conditioning, but it doesn't matter for us at this level of the course. We're going to use these terms interchangeably. And the idea behind the general principle of instrumental conditioning is that animals acquire adaptive behaviors through the experience of success or failure. Sometimes called operant conditioning because in this form of conditioning, the organism operates on the environment in some way. The cat presses a paddle. Okay, that's an operant kind of response. Whereas in classical conditioning, the animal doesn't operate on the response in any way. It just salivates or whatever it's going to do. It's also called instrumental conditioning because this conditioned response is instrumental in getting for the organism something that it wants, okay? So that's the general idea here. The organism is operating on the environment, changing it in some way, and the behavior is instrumental in getting for the organism some desired state of affairs. Whereas in classical conditioning, we see organisms forming associations among stimuli between bells and food, between conditioned stimuli and unconditioned stimuli. In instrumental conditioning, we see animals forming responses between their behaviors and the outcomes of those behaviors, between paddle pressing and getting out of the puzzle box. Okay? So again, by virtue of instrumental conditioning, what happens is that voluntary behaviors, not involuntary reflexive behaviors, but so-called voluntary behaviors like paddle pressing, it's not an innate reflex. These kinds of behaviors come under the control of environmental events. And again, the phenomena of instrumental conditioning are nearly ubiquitous in nature. All vertebrate organisms, at any rate, all vertebrate organisms and many invertebrate organisms can show the phenomena of instrumental conditioning. So that's a lot of organisms. There are a lot of species that can show instrumental conditioning. Just as Pavlov thought that all learning was a kind of variant on classical conditioning, so Thorndike and Skinner thought that all learning was a variant on instrumental conditioning. We now know that that viewpoint is also too extreme. However, it's very clear now that the laws of instrumental conditioning appear to account for much of the acquisition and maintenance and display of lots of adaptive behaviors. A lot of habitual behaviors are acquired through instrumental conditioning. Basically, anything that organisms learn to do under conditions of incentive. When the cat wants to get out, the animal wants to get fed or wants water or whatever, instrumental conditioning is what seems to be going on there. Okay, let's now compare classical and instrumental conditioning on a number of salient dimensions. There are at least 4 differences between these two forms of learning, and I think going over them will help you to understand what's going on here a little bit better. In the first place, in classical conditioning, reinforcement does not depend on the animal's behavior. Think about Pavlov's dog for a second. Bell is followed by food. Bell, food. Bell, food, and it doesn't matter what the animal does, okay? The animal's just sitting there. It's actually not doing anything. It's in this harness. It can't move around. It's not barking. It's not doing anything. Bell, food, bell, food, bell, food. The reinforcement, the presentation of the food following the bell doesn't depend on anything that the animal does. By comparison, in instrumental conditioning, reinforcement is precisely dependent on the cat's behavior. If the cat didn't press the paddle in the puzzle box, it'd never get out. Okay? And getting out is the reinforcement for the paddle pressing behavior. So the animal's got to engage in some kind of behavior for reinforcement to be presented. Another difference between classical and instrumental conditioning is that in classical conditioning, the behavior that you're interested in is elicited as a reflex by the unconditioned stimulus. What Pavlov wants to do is to condition the dog so that it salivates in response to the bell, okay? But the salivation is elicited as a reflex by the meat powder, okay? By contrast, in instrumental conditioning, the behavior is emitted freely by the organism. There's nothing that you can do to make the cat press the pedal, okay? It's just got to do it in its own sweet time. So there's nothing you can do to elicit this paddle pressing behavior. It's not any kind of a reflex. Okay, so here's a third way of putting pretty much the same point. In classical conditioning, what's being conditioned is an involuntary response, a reflexive response that is an involuntary response to some stimulus. What is being conditioned in instrumental conditioning is a voluntary response, a behavior that the animal engages in more or less spontaneously. Because classical conditioning brings involuntary reflexive behaviors under environmental control, there are relatively few behaviors that are subject to classical conditioning. Why? Because there are relatively few reflexes. I mean, compared to all the things that animals can do, reflexes constitute a relatively small part of their behavioral repertoire. So you can condition dogs to salivate, you can condition the eye blink reflex, you can condition the patella reflex, you can condition all sorts of reflexes through classical conditioning. But there's lots more that you can do with the instrumental case. You can condition animals to engage in not only all sorts of voluntary behaviors, but all sorts of combinations of voluntary behaviors. If Thorndike had had the patience to do so in his experiment, he could have trained his cats to sit down, scratch their right ears, scratch their left ear, wag their tails, and then press the paddle in order to go out. That whole pattern of behavior could have been shaped up by instrumental conditioning. Okay, so again, classical and instrumental conditioning represent somewhat different forms of learning, and they enable animals to learn somewhat different kinds of things. Quick questions on instrumental conditioning or the comparison with classical conditioning? Okay, classical conditioning and instrumental conditioning are different, but if you think about it for a second, most examples of adaptive behavior reflect some kind of combination of classical and instrumental conditioning. This is made clear, I think, by a form of learning that is often studied in the psychological laboratory known as avoidance learning. This is the apparatus used in some classic studies of avoidance learning by Richard Solomon and Lyman Wynn. Solomon and Wynn, lots of other psychologists as well, use dogs in these studies. This is known as an avoidance apparatus. It's a shuttle box. It's pretty big. That's about 8 feet long, about 4 feet high, about 3 feet wide. So it's a pretty good container for a dog. And what they did in these experiments is you place the dog in one side of the apparatus, and there are some lights inside that can deliver conditioned stimulus. And down here on the floor is a wire grid that can deliver a mild, not an aversive electrical shock, but not a lethal electrical shock or anything like that, mildly painful electrical shock to the feet of the dog. And what happens in this experiment is the dog will be in one side of the shuttle box, the lights will come on, and then a couple seconds after the lights come on, then the shock is delivered to the feet. And what will happen is the animal will just kind of naturally start moving around and will eventually jump over this barrier into the other side of the shuttle box. When the animal jumps into the other side of the shuttle box, the shock goes off, the tone, and the lights go off. Okay? Then what happens is the lights come on in this side of the shuttle box. A second or two later, the shock comes on. The animal feels the shock, of course, eventually moves over to the other side of the shuttle box. Shock goes off, lights go off. After a little bit of rest, lights come on, shock comes on a couple seconds later, and the animal moves over. It's a shuttle box experiment because what the animal learns to do is to shuttle back and forth. The initial responses on early trials in the experiment are escape trials because they occur after the shock has come on. Light is the conditioned stimulus, shock is the unconditioned stimulus. When you make the response after the onset of the shock, that's known as an escape response. But eventually what happens is the latency of the escape response begins to decrease, just like with Thorndike's cats in the puzzle box, so that at some point the animal will vault over the barrier and make the response before the shock even comes on. That's the animal's first avoidance response. Doesn't escape shock, it avoids shock altogether, and very quickly the animals learn to make this avoidance response just as soon as the conditioned stimulus comes on. So what's going on in this kind of experiment now is that the animal is acquiring two different kinds of associations. It's learning in the first place that there's an association between the lights and the shock. That's classical conditioning, where the animal is learning about the association between the lights and the shock. And then the animal learns that there's an association between vaulting the barrier and termination of the shock. That's instrumental conditioning, where the animal is learning an association between some behavior, vaulting over the barrier, and the consequences of that barrier. So again, the animal is learning two things, a combination of classical and instrumental conditioning. By virtue of classical conditioning, the animal comes to associate the shock with the light. By virtue of instrumental conditioning, the animal comes to associate vaulting the barrier with the removal or the termination of the shock. When you get up in the morning, you have a somewhat similar experience to these dogs in the shuttle box when your clock radio goes off. If your clock radio is anything like mine, when you set it to go off, the first thing that happens is that the radio comes on. Public radio or COIT or whatever it is that you listen to, KFOG. And then maybe 5-10 minutes later, what happens? Buzzer goes off, right? It's a very aversive buzzer. And then you've got to reach over to your clock radio and turn the buzzer off. But if you press that button in the interval between the time the radio comes on, the time the buzzer comes on, you can prevent the buzzer from coming on entirely. That's exactly the situation that these dogs are in. And you've learned the association between the radio coming on and the alarm coming on, and you've learned that there's something you can do either to turn the alarm off or to prevent the alarm from coming on entirely. It's very much the same kind of thing. And this analysis of avoidance learning is what is going on in a theory called the two-factor theory of avoidance learning, proposed by a psychologist named Maurer in the late 1940s. Okay, remember what happens is that there's light followed by shock. If the animal responds during the shock, it's rewarded by escaping from the shock. If the animal responds after the light but prior to the shock, it's rewarded by avoiding the shock entirely. And Maurer simply said, look, the first thing that happens here is that you condition fear to the light. The shock is painful, it makes the animal afraid, and you condition anticipatory fear to the light. And then what you do is you reinforce escape and avoidance by the cessation of the shock and the associated light. So again, this simply illustrates how this major form of learning combines both aspects of classical conditioning and instrumental conditioning. Okay? By virtue of classical conditioning, associate the light with the shock. By virtue of instrumental conditioning, associate avoidance or escape response with the termination of the shock. Two factors, one factor having to do with classical conditioning and one factor having to do with instrumental conditioning. Okay, classical conditioning, instrumental conditioning, two major forms of learning. What is it exactly that these animals are learning? Well, for a long time in psychology, learning was thought to be as automatic as reflexes. And what happened is that by virtue of classical and instrumental conditioning, dogs, cats, rats, pigeons, humans acquired connections between stimuli and responses to them. okay? And this is what's known as the stimulus response, or SR learning theory, which entailed 4 different assumptions, each of which are critical for understanding the theory. The first of these assumptions is the assumption of association by contiguity. The SR learning theorists argued that associations are formed when there's the repeated joint occurrence of 2 events, the conditioned stimulus and the unconditioned stimulus, the response and the reinforcement. The idea here is that associations are formed between stimuli and responses that occur close together in space and time. For Pavlov, the bells followed very quickly by food within a second or 2. For Thorndike, pressing the paddle is followed very quickly by escape within a second or 2. The general idea here is that the repeated joint occurrence, the repeated co-occurrence of 2 events, closely related in space and time, close together in space, close together in time, creates an association between them. And it's that association that the animal is learning. In classical conditioning, the association is between 2 events in the environment, the bell and the food. In instrumental conditioning, the association is between some behavior and its consequences, paddle pressing and escape, vaulting the barrier and escape. Okay, so that's the first assumption. The second assumption is what's known as the arbitrariness assumption. And the arbitrariness assumption basically says that by virtue of association by contiguity, any stimulus can be attached to any response. You can arbitrarily select any stimulus in the world so long as the organism can sense it, and any response that the organism can make and form an association between them. You can select stimuli and responses arbitrarily and form an association between them by virtue of contiguity. Association by contiguity and arbitrariness. Then there are 2 kind of hidden assumptions in SR learning theory, which also turn out to be important. One of these is known as the assumption of the empty organism. And what empty organism means is that you can understand an animal's behavior solely in terms of stimulus inputs and response outputs. The light, the meat, the salivation. The light, the shock, and the escape. All you have to know if you want to understand what an organism is learned is what the stimuli are and what the reinforcements are that are being associated. Put another way, these learning theorists thought of the organism as essentially a black box that connects stimuli and responses. Those of you familiar with computers or other kinds of engineering things know a black box is simply a device that connects 2 things and you don't know how it works. Okay? You don't know how it does these kinds of connections. And the SR learning theorists didn't know how these connections were made, and they didn't care. All they said was, all we got to know is that there are stimuli and responses, and the organism connects them up. We don't need to understand anything about the organism's inner workings in order to understand what it's learning. All we have to do is understand what stimuli are impinging on the organism and what responses it's making. And then finally, the final assumption of the traditional SR theory of learning is the assumption of the passive organism. The idea here is that the organism isn't active during the learning process. Pavlov's dog isn't trying to figure out what's going on in the experiment. Thorndike's cats aren't trying to figure out how to get out of the puzzle box. It just happens, okay? By virtue of the pairing of the bell and the food, the animal comes to salivate. By virtue of the pairing of the paddle pressing and escape, the animal comes to press the paddle. It's this assumption of the passive organism that actually gives us the metaphor of conditioning. Okay? The idea here is that learning is something that happens to an organism. When you condition your hair, you put stuff on your hair and it either gets less frizzy or it gets more frizzy depending on what kind of conditioning you use. Your hair isn't saying, oh, please make me softer. Please, please choose this one. Don't choose that one. It's not involved in the process. Something is being done to it. Similarly, in classical and instrumental conditioning, the prevailing view is that things are happening to the organism, but the organism really isn't actively involved in the process. All that's happening here is that behavior is coming under the control of environmental events. There's no sense here of expectations or free will or anything like that on the part of the organism. These four assumptions, association by contiguity, arbitrariness, the empty organism, and the passive organism, we now know are entirely wrong. But I talk about them because these assumptions dominated the psychology of learning for more than half a century. And you can still see their residues in some psychological theories today. More important, demonstrating how these assumptions were wrong left us a legacy of some of the most interesting studies in the learning literature, studies that we're going to talk about in the remainder of this lecture and the next lecture. We now know that there's a wide variety of experimental results that challenge each of these kind of common sense assumptions about the learning process and reveal that learning is quite different from what these early theorists thought it was. These experiments come in basically two forms: studies of what we think of as biological constraints on learning, and then later studies of what we think of as cognitive constraints on learning. Let's look at the biological constraints on learning first, because what they do is challenge especially this assumption of arbitrariness. Here's a classic experiment by John Garcia, then at the University of Utah, and his associates, on what's known as taste aversion learning, or what's known as bait shyness. In the real world, when animals encounter a new food, what they will do is they will sample the food. They'll eat a small amount of it, they'll go away and wait. If they get sick, they'll never approach that food again. They might eat something else, but they won't eat that particular food again. They'll avoid it. This is a phenomenon that's well known to ranchers who have to deal with coyotes. It's well known to farmers of all kinds. And what Garcia and his colleagues did was to bring this phenomenon of bait shyness into the laboratory in a particularly interesting experiment. The experiment is really set up as a kind of classical conditioning experiment, though as you'll see in a minute, it has a kind of instrumental conditioning quality to it as well. What happened in this experiment is that these subjects, which were rats, these were laboratory rats, were exposed to a compound conditioned stimulus while they drank water. Animals just drink water in their cages, and while these animals, a tube would come out delivering water, and while the animals were allowed to drink, they were exposed to a compound stimulus, which is that there were lights flashing in their cage. There was a clicking noise presented in the cage, like a little ratchet that was spinning around, and the water was flavored sweet with saccharin. So Garcia called this compound conditioned stimulus bright, noisy, sweet water. The animals were allowed to drink this for a moment or two, and then they were exposed to one of two different kinds of unconditioned stimulus. One group of rats got foot shock after they started drinking, which caused them some immediate pain in the foot. Another group of rats was exposed to a mild dose of X-rays, which, after some interval, made them sick, made them nauseated. Okay? So after, the foot shock group got immediate pain in the presence of the bright, noisy, sweet water. The group in the X-ray group got delayed nausea after some period of time, also in the presence of the bright, noisy, sweet water. What Garcia then did was to put the animals in a situation where they were allowed to select one of two sources of water. They were given a choice between bright, noisy water on the one hand. There was a water tap where the lights were flashing and there was a little ratchet noise. Or there was a water source that delivered sweet water flavored with saccharin. And what Garcia and his colleagues discovered was that animals would avoid the water, but the water source that they avoided depended on the unconditioned stimulus to which they had been exposed. Here is a schematic diagram of the experiment. All subjects were exposed to bright, noisy, sweet water. Some subjects were then exposed to foot shock, which produced immediate pain. Another group was exposed to X-rays, which produced delayed nausea. Okay, you got the experiment? Here's the compound conditioned stimulus. Here is the unconditioned stimulus. Here's the unconditioned response. And here's the unconditioned response for group 2. Now we give the animals a choice. They can either drink from a bright, noisy source of water, or they can drink from a sweet source of water, and here are the results of the experiment. The animals that were shocked preferred to drink the sweet water, but avoided the bright, noisy water. By the same token, the animals that were exposed to the X-ray avoided the sweet water and strongly preferred to drink from the bright, noisy water. Okay? So what's gone on here is that the animals in the shock group have learned an association between the taste of between the brightness of the bright, noisy water and the shock, and the animals associated to the X-ray have learned an association between the taste of the water and the taste. Here we have just the number of licks that they're giving. All right. So now we have two animals exposed to exactly the same conditions, same compound stimulus, same unconditioned, the two different unconditioned stimuli delivered at exactly the same time, but they learn two different things. The shocked rats form an association between the sight and sound of the conditioned stimulus and the shock. The poisoned rats form an association between the taste of the stimulus and their aversion. What is being illustrated here is that the animals don't learn the same things. Okay, these do this again. All elements of the compound stimulus are associated with the shock, but these animals only associate the light and the noise with the shock. They don't associate the taste with the shock. All the elements of the compound conditioned stimulus are equally contiguous with the X-ray, but the animals form an association between the taste of the stimulus and the X-ray, not the sight or sound of the stimulus and the X-ray. What this shows you is that the associations that these animals are forming are not arbitrary. Rats can't learn the association between taste and shock. They don't learn it. Animals don't learn the association between sight and sound and nausea. It's just not something that's possible for them to learn. Here is a similar kind of finding in another domain. This is escape and avoidance learning in pigeons. This is work by Robert Bowles at the University of Washington. And what Bowles discovered was that it was easy to teach a pigeon to flap its wings or to stretch its neck in order to avoid shock. Very easy to teach a pigeon that, but it is harder, in fact, it's impossible to teach a pigeon to peck a key to avoid shock. Even though it's incredibly easy to teach a pigeon to peck a key to get food, you can't teach a pigeon to peck a key to avoid shock. Similarly, if you look at rats, it's very easy to teach rats to jump up on a shelf to avoid shock. It's very easy to teach rats to learn to run in a shuttle box to avoid shock, but it's very difficult. It's not impossible, but it's very difficult to teach animals to press a lever to avoid shock. Bowles's insight is that the escape and avoidance responses that animals find it easy to learn are those that are part of their innate repertoire of escape and avoidance responses. If you're in a park and there's a little kid in the park, what do little kids do in parks? They chase pigeons, okay? Never was a little kid in the world that didn't chase pigeons in a park. And what do the pigeons do, okay? They run away. They flap their wings, they fly away. And in the process of beginning to fly, birds will stretch their necks as a preparation to taking off. These are natural escape and avoidance responses that pigeons have, and it's easy for them to learn to engage in those behaviors to avoid shock. Similarly, rats will run to in natural environment, run to escape predators, and they find running and jumping up on shelves to be very natural, very easy escape and avoidance responses to learn. Bowles's insight then was that avoidance learning capitalizes on each species' specific repertoire of innate escape and response behaviors. If the animals are required to learn to escape and escape and avoid, they can do that much more quickly if the escape and avoidance response that you're trying to learn is one that is part of their innate repertoire. Okay? So the general idea here is that the kinds of associations that are formed in classical and instrumental conditioning are not by any means arbitrary. Instead, their learning seems to be governed by what's now known as the preparedness principle in learning. The general idea behind the preparedness principle is that by virtue of its evolutionary history, every species is predisposed to form certain kinds of associations. These associations that the species is predisposed to acquire are what we call prepared associations. There are other associations that the animals have not been predisposed to acquire. We call those unprepared associations. And there are still other associations that are contra-prepared, meaning that by virtue of their evolutionary history, certain species, simply can't make those associations at all. Associating sight and sound with shock, that's a prepared association for rats. Associating taste with nausea, that's a prepared association for rats. Associating sight and sound with nausea, that's contra-prepared. They can't do it. They're not built to do that. Associating taste with foot shock, that's also contra-prepared. Rats simply aren't able to do that either. The implication of this is that you can't, after all, treat the organism as if it were empty. You can't simply arrange stimuli and responses so that they occur close together in space and time and expect the animal to be able to pick up on that. The first thing you have to do is that you have to understand how the organism is built. You have to understand something about its internal biological structure in order to understand what it can learn and what it can't learn. Rats evolved in such a way that they associate sight and sound with pain and taste with nausea. Birds, by the way, evolved in exactly the opposite way. Birds find it very easy to associate the sight and sound that surrounds their food with its gastrointestinal consequences, but they find it very, very, very difficult to associate the taste of food with its gastrointestinal consequences. If you think about it for a second, most birds are sight feeders. Birds walk around, they see a piece of grain on the ground, or they see a seed or an insect or whatever, and they peck at it. They're built to look at their food, okay, and peck at it. They have taste buds, they can taste food, but they're just not built to associate taste with nausea or anything like that. Okay? So you have to understand the individual's biological workings, how the organism's brain, nervous system has been shaped by evolution in such a way as to make it easy for it to learn some kinds of associations and hard for it to learn other kinds of associations. Okay? So first point here is that we've got these problems of learning that undermine certain assumptions of the stimulus response theory of learning. First, undermining the assumption of arbitrariness. You can't just pick stimuli and responses arbitrarily and expect animals to learn them. Animals are prepared to learn those stimulus response associations that they're predisposed to learn by virtue of evolution. And you can't construe the organism as empty. You have to understand that evolution has shaped its nervous system so as to prepare it to learn some things and to prevent it from learning other kinds of things. Finally, it turns out that some of these experiments also undermine the principle of association by contiguity. Let's look at the Garcia and Kaling experiment again. Here we have the bright, noisy, sweet water coming on, coming off. Here is shock coming on very quickly after the bright, noisy, sweet water. But look at the X-rays. You don't feel X-rays, okay? There's no sensory aspect to being irradiated with X-rays, but the animal does feel nauseated a long time afterwards. What's happening here is that in the rat case, the rats are forming an association between taste of food and its gastrointestinal taste of water and its gastrointestinal consequences, even though there's a long period of time separating the stimulus from this response, okay? So the Garcia experiment is really kind of a triple whammy as far as the traditional SR theories of learning is concerned. It undermines the assumption of arbitrariness, it undermines the assumption of the empty organism, and it undermines the assumption of association by contiguity. We'll attack these assumptions of SR theories of learning from the cognitive perspective in our last lecture next Monday, on Wednesday. Thank you very much.